overall site of the OSU Cascades campus is a pretty neat story in itself. Behind me is a pumice mine and a landfill. As we close the pumice mine and regrade and use material from the landfill to fill in parts of the pumice mine, we're reclaiming a brownfield site on which we're building our new campus. And our journey with Edward Ray Hall and mass timber started actually in the Oregon legislature. The legislature asked OSU to include the use of Oregon and Northwest forest products and mass timber in the construction of the building. And we really embraced that challenge, and now, several years on, we couldn't be happier with the result. The building was actually constructed at the same cost per square foot that it would have been if we built with steel and concrete. That was managed without any special government subsidies, and we realized a whole lot of benefits with the mass timber, so OSU is just very pleased with this project.
This is really an architect's dream come true. When OSU approached us back in 2019 with the brief for the project, they had 3 big goals that they wanted to achieve. A building that served as a prototype for flexible, adaptable, to be able to change to multiple different types of learning. They also wanted it to be a demonstration for net zero energy. This entire campus around me is going to be a net zero energy campus. And third, they needed it to be a meaningful use of mass timber. Any one of those goals would have been extremely exciting for an architect such as myself, but having all 3 of them in one project, it's really the project of a lifetime.
One piece of this that I think is really important to remember is that this building is going to be here for the next 50 to 100 years. We have to think about not only what we're going to use it for now and the flexible and adaptable nature that we are chasing, but also how can we make sure this building is moldable for future use, essentially. We need to have spaces that can be used for general purpose classrooms, and then later on in the day be a lab for maybe outdoor products or for science uses. Maybe down the road, 5 years, we want to turn this into offices.
This is a space, you can see the seating area behind me. It will function both as a stair and a place to sit for large lectures. The floor of the space here is large enough for events and will be sort of a living room space for the building on a daily basis where students can study. It can also serve for art exhibitions and other types of events.
Net zero energy essentially means that you have all of the energy produced on site that your building uses on an annual basis. One of the key aspects is being able to get natural daylight in the space. And here you can see the windows go all the way up to the top of the ceiling, allowing the light to go deeper in the space. For architects, a rule of thumb, the room depth can be no more than 2 times that window head height. Here, because of the CLT, we didn't have to have a perimeter beam, which allowed us to push that window head height higher up to almost 14 feet, which then evenly illuminates this 28-foot wide classroom. Works perfectly, don't even have to have the lights on.
We worked closely with the architect and the city to arrive at a building type for the project called Type 3B. It really allows for a non-rated structure, so we don't have to have excess fiber for fire or char protection on the structural members. But as you do that, then the building envelope starts to be a rated element. So we work closely with structural to determine a cantilever that would work with a thin CLT panel. And we wanted to achieve that cantilever so we could pull the column into the space and not have to have that be part of the rated assembly. The added benefit we found by pushing that cantilever a little bit further was we created a little bit of a gap between the outside envelope and the column itself. We could then utilize that to run piping to serve a low energy system called sensible fan powered boxes to achieve some of our net zero goals.
For us, we thought if we could just get mass timber like CLT for the decks, that would be meaningful. But working with our partners, Swinerton Builders, we learned that actually it was more cost effective to do the whole project out of mass timbers, columns, beams, as well as the CLT by Boggin Timbers for the decking. And that's really where the genesis of this project and the success of this project is that we complement each other.
One of the exciting achievements with this project was not only being able to demonstrate the use of mass timber in an academic building, but to be able to source the wood locally. All of the glulam columns and beams came from Eugene, Oregon, very close to the project, and the mass plywood panels came from Lyons, Oregon. The ability to incorporate local wood really contributes to the story of the building and its spaces.
Early on in the permitting phase, we had a couple different options that we were researching as far as the lateral system for the building, and ended up choosing to go with a concrete shear wall system. And the significance of that is really being able to kill two birds with one stone. We could erect the shear walls all the way up ahead of the mass timber structure and be able to brace it back. That really allowed us to pick up the speed of the mass timber structure, because the mass timber can be erected at such a faster pace than a cast-in-place wall. So we were able to go up first all the way to the roof with the concrete shear walls, and then catch up to it eventually with the mass timber structure.
So one aspect of this that was really exciting was the coordination and the level of coordination between the mechanical, electrical, and plumbing trades. In particular, they had to spend a lot of time up front to pull all the mechanical, electrical, data, plumbing, all into this hallway so that it was all coordinated and we had everything at the right elevation so there were no clashes. In addition to outlining where all of the conduits and piping ran in the cement slabs so that we can coordinate the holes in the CLT to be pre-manufactured before the CLT got installed in the building.
Being able to prefab all the penetrations within the mass timber components allows us to reduce the amount of on-site labor. The speed of all the rough-in that it takes to put all of this work in place has reduced pretty significantly.
So the outcome is that each of the offices and classrooms and lab spaces really have that clean, open feel to the ceilings, while all the mechanical is centered in this hallway. A lot of folks look at the hallway and say, well, should we put a screen in there, or should we kind of block the view of that mechanical system? And really we decided to open that up and celebrate it as one part of our institutional learning. Our Energy Systems Engineering program is already doing studies on the way that Ray Hall is intended to operate, and really to make sure that we're going to fall within our net zero energy goals, but then also looking at how the campus will operate as a whole if we continue to repeat this prototypical design.
Everyone knows that 2020 had a lot of challenges related to the construction industry. And it really started last spring with the start of the COVID-19 pandemic. From there, we've had everything from wildfires, which also led into some lamb stock delays. And we were able to really work as a vertically integrated team with the design team, with OSU, to mitigate what could have been 16 weeks of impacts down to only 2 weeks, just by really thinking outside the box and looking for different types of solutions to bring this project in on time.
As I reflect on our project and I think about the priorities that we had, the different aspects of it that were important to us, I also think about the way we approached it and the pieces of the way we approached it that really got us some results. Prioritizing the people in the project and the relationships was a key aspect of that, but I also think that finding a CMGC team that would work well with our architect, it's kind of an odd group to bring together sometimes. That was one key aspect of that, but additionally, finding a team that had some level of mass timber experience in the past and had the supply chain connections to be able to guide the team through how to make those choices in the project that will get the most benefit. How do you remove the waste in the project while bringing the beauty of the wood out, and then also increasing the adaptability and flexibility of the project? Having a team that focused on that together, bringing ideas together, prioritizing them, and then using a zero-based budget to get rid of the bottom end of it, well, that was a great result.